topic of this presentation is going to be around creating workflows on GitHub. And to like gain some more context here, let's like go back to the very problem. So who doesn't know this approach of infrastructure as code or configuration as code? Who isn't familiar with that? Everyone is, so that's awesome. So that's actually like the modern trend and the way to go when we talk about basically anything. Like instead of clicking around the UI, you just code some kind of configuration and keep it either in some kind of like programming language or YAML or JSON or whatever else. And this is the current trend. Even Jenkins, the old Jenkins, even has its own ways to describe the pipelines and the jobs. So on Jenkins, we have Groovy that's like dominated this area. You can have such declarative pipelines there. You can also use some custom Groovy code to define the pipelines, and it's really powerful. Also, I worked in Amazon, and they had this custom built Ruby-based. It was called like live templates that allowed us to create such pipelines in Ruby. And when talking about some more like open source or like widely available solutions, we have, for example, Travis CI or Circle CI, or probably also GitLab, GitHub, and they kind of went this path of JSON or YAML. So not sure about you, but I don't like YAML or JSON for such stuff. They are good to simply express simple data structures like a list of maybe people or some simple entities. But once we go deeper and try to express some logic into them, it starts to get really messy. So I just thought one day, because I was working on this project where this YAML was getting really ugly, like 200 lines of code, several workflows that shared certain pieces. So I thought, okay, let's try to use some programming language to solve these problems, where we could extract some even simple constants like names, or maybe some block of functions, and simply use familiar tools like we have the IDE, which has the tooling for extracting stuff, and more like to be a programmer, not like a YAML programmer, right? It's the joke. No, this joke like, hey, I'm coding JSON. So yeah, here's this library I came up early this year. It's called the GitHub Actions Kotlin DSL, and just what kind of issues it tries to solve. First of all, we deal with a real programming language, so it comes with a whole bunch of benefits. Whatever Kotlin gives us, so type safety, first of all, also superb IntelliJ support. You basically, the IDE basically talks to you if you write the code, right? You get all the IntelliSense kind of features. You can extract some pieces to separate files. You can even make a web service call to fetch some data and then build the workflow. You can like do some really crazy stuff. I'm not saying that all of them are good practice, but you get the power of a programming language. It's crucial to understand that it's not about Kotlin running like in runtime of the workflow. So think of it like a build system. Imagine Gradle. It has these two phases. The first is the configuration phase, and then comes the execution phase. In the first phase, the configuration phase, Gradle tries to understand what kind of tasks it's going to execute, like builds a plan, right, of this build process, and then executes this in the second process. So this library actually tackles only the first phase, because once we get the YAML, because that's the goal of the library, to take some Kotlin and produce a YAML. Once we get the YAML, we don't have a chance to do anything more for now. But I will share some ideas how we can go even further. Okay, so let me just try to write a simple workflow. I have some workflows here in this library, but we'll start from fresh blank slate. Let's call it my micro workflow.main.kts. So for those who don't know, Kotlin also allows writing scripts like in a self-contained files. So now all we need to do is to write this shebang user bin env Kotlin. This will sure, of course, I can. There's some fancy keystroke for that, but I'm just going to increase the font size. Okay. Let me go with 20. Is that better? Yeah. A bit better. Yeah. Okay. So in a second, I will also change. Okay, I can actually do it now. So now we need to change the mode of this file to make it executable. Hmod plus X GitHub workflows like workflow. Yeah, and now you should see that this file is here and is executable. You can see it here. Yeah. Okay, now we need to add the dependency on the library. So we do it in Kotlin scripting by writing add file depends on, and the Maven coordinates are IT, my humble surname, GitHub Actions, Kotlin DSL, and the newest version is 0.17.0. And now we can start coding. Wow, it said it cannot find me. I'm here, come on. Okay, so maybe let's take a look at some workflow in YAML so that we know what's our goal actually and where we are aiming. So every such workflow has a name, then has this on section, which means which triggers are defined for this workflow. So for the basic ones, this can be simply pushing a change to a branch, maybe opening a pull request, but some other fancy ones are possible, like schedule, maybe run several times a day, or maybe opening some kind of issue. I don't know, there's a bunch of them. And then we have a list of jobs. It's actually a map because it goes from the job ID to some job definition. So on the top level, we have a collection of jobs. Then each job can consist of steps, and everything is like wrapped in a workflow. So this is the naming of this of this domain. So if we want to create a workflow, then just write a workflow. Workflow, yay, my workflow. Yeah, I like using name parameters because it makes it all clear what's what. So let's write it like this. And now ID should talk to us. Talk to me, what should I write? Oh, okay, I don't have values for block on source file target file. So block will be this whole curly braced piece at the very end. So let me add it now, and we'll take care of this later. So now we also need this on, so a set of triggers. For now, I will keep it simple and will say that simply on every push to every branch, just to keep things simple. And now I have to specify two paths to files. The first one is the source file, and it's like imagine the repository root, and from this we want to say to this library where is this script. So by convention, I recommend to put this scripts into .github workflows directory. So let's write it. My workflow main KTS and target file. So where the library should create the YAML file. Let's say it's that. Okay. So now I don't see any compilation errors around the parameters. So we know that all the mandatory arguments are in place. So now let's create our first job. So this is job, no surprise. ID is the key that you saw in the YAML. So this is this. let's call it, maybe, I won't be too original here. ID, okay, what else? We also need the block, so let's put it here, and it said that also we need runs on. So basically any job needs a runner type. So think of it like an operating system or kind of environment where it runs. So I usually use Ubuntu latest because it's just Linux, and there are plenty of workers like this, so it's the easiest part here. And first thing to note that the library comes with predefined set of workers, so we don't need to look up any docs of GitHub. There's just a list of it here accessible from our IDE and as you type. So that's like one of the benefits. And let's say we want to write some hello world. So there are two kinds of steps in GitHub workflows: running a custom command or running an action. So GitHub has this notion of action. Think of it like a reusable piece of logic that has some inputs, has some outputs, and does something on your worker, like maybe check out your code from Git repo. This is the most popular one because you have to first check out the code to like do anything else with it. Or you can, for example, create an issue, or you can, I don't know, send some message to Slack. You can do various things, and developers can actually create custom ones. So it's really easy. So first, let's start easy and just print hello. And now let's try to run it. My workflow main KTS, yay. It takes a while for it to, okay. So it got printed, but actually no YAML file was created. That's expected, because in order to create it, this file, you need to call a function on this workflow called write to file. And now it should work. Okay, it's here. So you can see the file. Let's take a look at this from the very top. So first, there's some comment just to note that this file is not intended to be manually edited. Then you have the name, the triggers, also the jobs, and the command is placed here. But you may wonder, why do we need this piece? Like, we didn't write it in our workflow logic. So what's the goal here? So to understand it, we have to realize that using this library, we won't be able to replace the YAMLs. It will be like next to our YAMLs, and it's only some kind of new interface for writing the workflows. So ideally, we would like GitHub folks, so Microsoft now, to support such kind of stuff, but it's like almost impossible. By the way, I sent some requests to them, but no answer yet. So the goal now is to have this YAML so that GitHub can still run it, and have this main KTS file so that we can conveniently edit this workflow. And what happens if the two files got out of sync? We have a problem, right? Because like you can probably realize the consequences. So this first job here called check YAML consistency basically calls this script and compares it with the YAML. It compares the output from the script with the YAML that we have in this repo. Once it confirms they are the same, we carry on. And if it's not the same, we fail. So like a safety check, consistency check. Okay, so we have this first simple step. Let's try to add a new job, but to make it a bit more difficult, so that the first job waits for the second. So kind of dependency thing. I will make it really simple, so I will copy this one and call it my job, my other job. And hello, maybe bye. And to express the dependency, we need this needs parameter to the job function, and you can then specify a list of jobs. But okay, what do I need here? I need to pass a list of jobs. Okay, and this function conveniently creates a job. So in order to define this dependency, we just need to assign whatever is returned from this function to a constant. And that's all. Let's see if it works. Okay. And let's see, we have two jobs, my job and my other job. And this needs clause always contains this check like YAML consistency. So like imagine it's not there, but there's also this my job here, the dependency. So it works. And now let's get a bit more abstract. Let's say that I want to have such jobs, but like times 10, because for example, I need to do something in parallel or maybe in chunks. So in Kotlin, I would just do it like the Kotlinic way. Maybe just some range from 1 to 10 for each. Whatever here, like a name of the parameter. Let's move it here under this block. The IDs have to be unique, so I need to add this job ID also here, and I want to also display this ID in this echo command. So something along these lines. And let's translate it to YAML. Yeah, we've got 10 other jobs. So as you can see, we can use all the powers of Kotlin. Once you get familiar with the way the DSLs are created in Kotlin, you can just do whatever you want. And as I said, even fetching some extra data is viable. And remember that under the hood, there's JVM, so all the JVM-related ecosystem is there. For example, you can have some piece of code extracted to a separate library and then add a dependency here. Or maybe you can have some other KTS script just next to this to have some common piece of code. So this is really powerful. And so now let's see what happens if we want to call some action. So for that, we have a function called uses, because it's the keyword used also in YAML, GitHub YAML. And now we need some action. So the most popular one is checkout. It maps like to git checkout. And it should, okay. So now we see that there's checkout v2, which is deprecated, and v3 is like the current one. We have to instantiate it, okay, like this. Let's see if it works and what it produces. Some warning related to the fact that I don't use it, so not a big deal. Yeah, so here it uses the checkout. We may also, for example, there are a bunch of arguments here. So if you click inside this class, you have all the documentation fetched from GitHub. Actually, I will show you in a minute how it's done under the hood. So, for example, I want to check out some branch. We need the ref argument. My branch, it's all type safe. You are sure that the argument name is correct because it's just type safe. And here you have the branch name. So you may wonder, how do these actions enter the library? In what way can I use them? So initially, I was coding them by hand. It was really tedious. And I was even writing unit tests for each of them and for each argument. But after like 10 of them, I got really tired of this and I decided to generate the code. So I will show you a module, like internal module, that the customers don't need to be aware of it, but I will show it to you as this talk is devoted to solely to this library. So here we have a file that defines all the actions that are available in the library. So for example, let's take a look at this checkout actions checkout v2. Yeah, so here. So each such wrapper request maps to a single action. Here we have the coordinates, and here we have a chance to define like custom typing. So by default in GitHub, all inputs are strings. And here, since we are in Kotlin, we have a chance to even use some enums or basically whatever you want. The library gives us some basic like building blocks, like types the boolean, integer, maybe some enum, maybe some integer with a special value, like here. It's pretty nice, like it's a good example. So then once we have this list wrappers to generate, we use a generator that uses Kotlin Poet. It's a library for Kotlin basically focused on created Kotlin code. So we use, let me maybe show you, it's not that hard. So let's go to the very top, generate wrapper. This is like the entry point. First, we fetch the metadata from GitHub. So each action, maybe to show you, github.com actions is the owner of the actions owned by GitHub, and checkout. This is the action that we've just used. And each action has this file called action.yaml, which basically gives us everything on the plate, all the inputs, all the outputs, the documentation. And that's what is fetched inside the generator. We then iterate through all the inputs and place the documentation where it belongs. The API of Kotlin's Poet is a bit verbose. It's a bit like Java's, like with all the builders. But after all, it's like possible to start using within like a day or two. So I guess this is the current way to go to generate code for Kotlin. And you may ask, okay, so what if some action owner adds a new input, or maybe some other version appears? So ideally, we would like it to be 100% automatic, but now it's like half automatic. We have two jobs that run every day. One job, let me show it here. One job reports an issue on GitHub, on our GitHub. If there's a new version of a given action, then I can just open this code, add a new section in this file, a new wrapper request, and maybe mark the old one as deprecated, and we are done. And the other case is where a given action with a given version gets a new input, or maybe some type is changed, or maybe something in the docs is changed. Then we also have a job that compares whatever is in the source code of previously generated wrappers and whatever would be done right now. So here in the library module, you'll see this src directory, and then apart from the main and test, like Gradle source sets, we also have this like other part of the main source set, which is called gen for generated, and here you have all the actions grouped by the owners. Also on the docs for the library, you have this section called supported actions, which is basically a nicely presented list of actions that you can use. You can click in each of them and see its code, so it's pretty convenient. So yeah, this got a bit more scalable, but of course we won't ever map every action on the planet to this library. So it's for now it's like per need basis. If you need one, you can either request it or use some other API of this library to like use a custom action. It's also possible. Okay. Let me show you one more thing that is pretty brand new. One of the contributors, Jean-Michel Fayard, if I pronounce it correctly, he's from France. He came up with this idea of converting existing workflow in YAML to Kotlin. So imagine that you have a existing project and you really like this approach, and you can start using this library with the new workflows, but maybe you also want to convert the existing ones. And let's try to do it actually. There are docs for it. So script generator, we need this repo here cloned, and let's try to generate this existing build workflow. So this file build.yaml will go as input, and as output we will get the generated file. Okay, so now we need GitHub workflows build YAML, and let's see what happens. Well, that's pretty quick. I guess my cache is warm. Okay, and now we can browse it here. Build main KTS. Okay, so you see that this code is pretty not well formatted. Maybe let me use my IntelliJ plugin. Yeah, that's a bit better. So it should work, it should compile, but I guess it also needs some manual adjustments to make it maintainable. The bottom line is that you have some starting point to use, and you don't have to look up all the features of the library. You already have them on the plate given this output. So yeah. So do you have any questions? Maybe there's something on the Slido, not yet.
Whoa, okay. So let me first start with it's amazing job, and I'm really crazy impressed. That's really a cool library. And one question, could you open the result of the first one, the one that you generated from Kotlin, and could you show me the YAML file?
You mean this one, right?
Yeah. So on a top, you have this separate job for checking YAML consistency, and I totally get why it's here, and that's a cool thing. But is there any way to, so we don't need it so we can always get it in sync? So some automatic action that we will just include, for example, let's get a different comparison. You don't need to have Gradle if you want to build up the Kotlin app. You have the Gradle wrapper that's going to download it, process it, and keep it running.
Yep.
So is it even possible to get something similar here to just get it always working out of the box?
Partially, yes. So this library doesn't really, it's not opinionated. It gives you some utilities to implement various techniques. So this is the default one, right? If you have a single file, then this piece is generated. You can opt out of this by passing this flag add consistency check, and then you say that I know what I'm doing, and now you have several ways to go. The first idea is to have an action, as you said, that is triggered on every change in this main KTS files, and simply does what you say. So generate the YAMLs for you. The problem is with that is that once you have the action on GitHub running, and you change the YAML, it's not possible to trigger another action from this action like the first one. So GitHub intentionally prevents from sort of recursing further. Not sure if it's a bug or a feature. I guess it was well thought by the engineers, but it would be easier for us if it was actually possible, right? So for example, this workflow changes the YAML, and then the YAML gets executed as a workflow, and then we go on. But for now, so it will be possible provided that you then trigger this manually. Yeah. So the workflow does the change in the YAML, and then you have to take care of this later manually. This is the first approach. The second one is, for example, when you have let's say you have a PR in GitHub where you change a given workflow, and then you perform the check. So, but then you have to trust your colleagues and yourself that you won't modify it manually. I guess it's something to be agreed in the team, but in terms of any mechanism, it would be needed to maybe developed further, right? So each solution has its pros and cons. In terms of running time, this consistency check for the simple workflows, given that they don't call any external service, they take approximately 20 seconds. So it's not like a big deal, especially if you do some heavier build later. But yeah, and the holy grail will be that GitHub is aware of such generators, not even about Kotlin, but simply aware of such executables that produce the YAML on the output, and then it would be easy peasy because GitHub would take care of this. But it's like the future, not sure if it will happen. For now, it's just, so in this library, we have several workflows, and then we have this single file that includes all of them and calls write to file on like all of them at batch. So this simplifies it a bit to manage all these workflows. We don't need to call each script manually. We have this like single one. But it doesn't that directly solve the problem that you mentioned, but it makes stuff easier. If you or anyone else have a better idea how to tackle this problem, I'm open to discussion, right? Because yeah.
I actually got like some idea that just popped into my head. Maybe it's a dumb one, but let's talk about this. Like you've mentioned two approach, but maybe the third one would be to kind of like, once we find out that there was a change to the Kotlin script, then let's trigger the code on like some GitHub action and let's make a commit to the repository.
Yeah,
I guess we would be kind of like skipping it's like not perfect. You make a commit that you need to pull changes after some time. But yeah, I guess then we could skip the problem with the kind of like recursive calling that's forbidden. Because it would trigger like a separate pipeline since it's a separate commit.
Actually, no. I guess no. Oh. That would be pretty nice, but we've tried that and it doesn't work. So GitHub is apparently smart enough to know that a given action created a commit and it shouldn't trigger further workflows. Oh. Yeah. Okay, so no way to go. Such here. A loss, right? But maybe there's some way to fool GitHub. I read that it's about the token, GitHub token that GitHub sees it's there and it's the same. So it says, okay, I don't continue. Maybe there's some hack for it. Yeah. So that's it for now. Any questions on Slido? No. Any more questions from the room?
Not necessarily, but as a side note, I hope that actually more build tools will go that way that you try to achieve.
Do you want the microphone? It will be
not necessarily. I will speak loudly.
Because we send it like we record it. Please try to.
Yeah. Okay. So basically, I hope that more tools, the continuous integration tools, will go the way that you try to pursue. And the first time I saw a similar approach to use Kotlin and DSLs for continuous integration was in TeamCity. So maybe
JetBrains.
And JetBrains, like you could suspect it, right? They know the Kotlin, they create it and they used it immediately in their own tools.
Exactly.
So this is exactly what I expected from the other continuous integration systems to also choose, but unfortunately this YAML and JSON approach is very disappointing to me too. So I'm really glad that you tried this stuff. I would gladly see something similar for GitLab. Maybe based on your work, it would be easier to create like a different version for GitLab.
Exactly. Yeah.
So
of course.
Good stuff. Thank you very much.
Thanks a lot. Yeah. Also, I checked if on Jenkins if they plan to provide some Kotlin API and they sent me a ticket for Python. Like someone asked adding Python support, and they just laughed at it. And they resolved it as a won't fix, and they simply are committed to Groovy, which, by the way, is way better than YAML, right? So anyway, I guess it's good enough. This Groovy stuff, it works well with DSLs. So yeah, right then. So in case of no other questions, thanks a lot. And now please enjoy the snacks, the gadgets from Dynatrace, which, by the way, is the sponsor of this event. Yay! And thanks a lot.